Hi everyone. I just wanted to take a moment to record this video to go over subsetting again and give you a little bit of help with the Portfolio 3 array and how I expect you to put that together. So first off, let's import pandas and we're going to take a look at the penguin data. Of course, this is different than the sloth data, but it's going to be very similar, uh, a very similar process. So we call that. And then what we want to do is think about the fact that we need an array of counts of different levels of our factors. So for example, if we look at the columns of, let's see here. Empty of columns. So if we look at our columns here, let's say we're interested in whether species and island are independent of each other. So what we need is a array such that we have species 1, species 2, and we're actually going to make that into a markdown. And we know there's species 3. And then island 1, 2, 3, etc. And so we need to figure out, okay, how many species 1 in island 1? How many species 1 in island 2, island 3, etc. Same thing for species 2, same thing for species 3. And that's our array for our chi-squared a test for independence, what happens to be what you're going to have to do for Portfolio 3. So how do we get these numbers? We can have Python count for us. So let's do another code block. And first off, we need to count the number of species 1 and island 1. So let's subset. So first, let's see df species. So it's not going to work now. Df species dot unique. We're going to encapsulate that in a print. So we have see. Oh, what's that? So we have Adelaide, Chinstrap, and Gentoo. So let's just do species 1 is Adelaide. And I'm not going to do this for all of the counts that you need, but this is something you can do over and over again, just changing small bits of the code to get the numbers that you want. So Adelaide, we're going to subset. So the subset df where df species is equivalent or equal to Adelaide. And so there's our subsetted data. Now, we also should probably figure out how many islands there are. So we're going to do unique island. I don't know why it keeps saying it like that. So we'll run that. Okay, so we had Twerkson, Bisco, and Dream. So AT will be the Adelaide, the count of the Adelaide penguins in or on Torgerson. So we're going to subset Adelaide where Adelaide Island And we're gonna do Torgerson. And then we're going to print, and we're going to take the length of some column in this subsetted subset table. It doesn't matter which one, because it should have, each column should have the same number of rows, so it doesn't really matter what column we call, we just want to count how many rows there are. So println, and let's see, at, and let's do island. As I said, it doesn't matter which one. And we take all of that. All right, that's 52. So species 1, island 1, 52. Now as for island 2, we're going to copy those 2 lines, and we're going to go A, B for Bisco. So we're going to change Torgerson to Bisco, and we're going to change this T to a B, and then we have 44. And we can finish that. And finish that by hitting the correct keys. And then the last is dream, so AD, dream, AD, AD, and that, and that's 56, so 56. Okay, and that is the beginning of the first row of our array. So we need to then do this for species 2, which is Chinstrap, and species 3, which is Gentoo. Of course, it's going to look different for your sloth data because there's going to be more subspecies. And there may be a different number of endangered levels of endangerment, but I'm not sure. It's up to you to find out. And so once you have that, I'm going to open up the textbook really quick. And chi-squared. And we're going to run a chi-squared. We're going to have to create our array. So let's a new, and so we have our array, and it looks very similar to what I created up here. And so we have 52, 44, 56, 52, 44, 56. That's our first row. Our second row is going to be whatever data we get from the Chinstrap, and our third row is whatever data we get from the Gentoo. And it's up to you to do that if you want to follow along with this video. And then we can get rid of this here. And, oh, of course, np, so import numpy as np, and that should work. And let's print observed, and there's our array. So that works really well. And then, of course, you can use that to do your chi-square. So that's basically how I want you to complete Portfolio 3. I also would like you, once you've done the chi-square test, I want you to interpret the results. Looking at your array, looking at the p-value, and come up with some biological reasons why you see the pattern that you see, or the pattern that you expect isn't there, or it is the pattern you expected and why. And that sort of insight's really, really important, because the test itself is actually quite straightforward. A couple other pieces of information for your portfolio, make sure to include your name at the top. I've noticed that none of you have done that, and I've been doing my best to keep the portfolios properly assigned to folks, but it's going to make my life a whole lot easier if you put your name at the beginning in a markdown block. It's just going to make my life so much easier. And two, I've been posting copies of your portfolios on Brightspace as feedback. So if you haven't looked at those, you definitely should just download them into your uh, Jupyter Lab instance, and you can open it and look for comments. I have been taking some time to look at, to go through and correct things and add comments, so hopefully those will be useful to you. With that, I will see you all later.